All right, guys, for today's lesson, you're going to need page 193 out of your workbook. Okay, so we're going to actually be on page 193, 194, and 195. All right, so we've been talking about slope, and today's lesson, we're going to look at taking that a little bit further here. So it says, example, Mr. Aba drew this graph on the line, drew his graph on the board. What is the slope of the line? Okay, look how you could find the slope based off using rise over run. So that's a concept we've been using now. All right, so rise over run, again, what they're doing in this example down here, they're picking 2 points that go through the corner of a box. So there's 1 point, and then we see another point up here. And when we are figuring out rise over run, well, from this point, the leftmost point, how many units do you need to rise to get to the level of the next point? In this case, it would be 2. And then over how much you have to run to get to the point on the line, which is 3. So 2, 3 that way. So our slope is 2 over 3. So down here, solution, the slope is 2 over 3. Okay, down and under apply it, number 1. The graph shows how many skateboards a company made over a period of time. How can you show that the slope is constant? So there are several different ways we can look at this one. Number 1, we can just go ahead and do what we just did, find 2 points on the line. So let's say I pick this point right here, 0, 0, goes through the corner of a box. And looking at these next ones, it looks like the next corner that it goes through is that one. Okay, so then I see that my rise over run, I'd have to get all the way up to this level. And then I have to run over this many. So if I'm just counting the squares, 1, 2, 3, 4. My squares going up is 4. Going across, 1, 2, 3, 4, 5. Okay, and I know that the 4 up doesn't necessarily represent the 4, but we see it's a change from 0 to 200,000 for skateboards. Okay, now if I pick 2 other points, or if I use this point and I pick another point, looks like goes to the corner of a box right there, I would double check to see if it's the same thing. So to get up to this level, I have to rise up to there. So that is, again, a rise of 4 and a run over of 5. So you say, yes, you can use rise over run with several points to prove it is the same. Okay. Now also, we talked previously about using slope triangles. So the slope triangles is basically doing the same thing we just did, but backwards. So if I make a triangle, a right triangle, I see it would be this way. If I do another one, we see that one as well. So I could also say slope triangles are congruent. So if your slope triangles are congruent, then you know that slope is constant, meaning it's going to be the same rate of change. Okay, let's turn the page. All right, page 194, number 2. Gavin makes bracelets by stringing beads on a cord. The cost of a cord is proportional to the length of the cord. Gavin graphs a line that shows the cost per yard of cord. 2 points on the line are 3/4 and 3 and 7.5 and 30. What is the slope of the line? So in this case, we don't have a graph, so it's probably easier just to use the slope formula. So the slope formula reminder is the second y minus the first y over the second x minus the first x. Okay, so I'm going to go up here, I'm going to label my points. So I know this is the first x, that's the first y. This is the second x, and this is the second y. So then my work, if I set this up, second y, 30, subtract first y, 3. And then second x, 7.5, subtract first x, 3/4. Okay, and it's okay to use your calculators here because we got some fraction work if you're not able to do that mentally. Up top, 30 take away 3 is 27. You know, on the bottom, just a reminder, if you're using this calculator, it does have a good fraction feature. So we can do 7. And if the ABC key, that is your fraction key. 1, ABC 2. So that represents 7.5. Subtract 3, ABC 4 for 3/4 equals, and we see we get 6 3/4. Okay, so right now I'm at 27 over 6 3/4, which is kind of confusing because we have a fraction and a fraction. We don't like to have that. So I'm going to simplify this further. I'm going to take 27, divide 6, ABC 3, ABC 4. And we see it simplifies out to 4. So my slope is 4, or 4 over 1. But the question asks, what does it mean in this context? Okay, so here, back up here, it says cost per yard of cord. Okay, so our price would be $4 per 1 yard of cord. Okay, so down here I'm going to say my slope is 4, but then I'm also going to explain it. The cord costs $4 per yard. All right, number 3. So let's go down to this one. So number 3, what I would do is I would go ahead and look at this graph and try to find 2 points that go through the corner of a box. So I would choose this one, and let's say maybe this one. Okay, and again, you could have chosen a different one if you want. This one up here is also a possibility. Okay, so what I want you to do now is I want you to go ahead. You can either look at the graph, figure out rise over run, or do slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and then figure out which one of these is the correct answer. Okay, go ahead and do that now. Okay, after you have your answer, down below it says Elon chose D as the correct answer. How might he have gotten that answer? All right, take a second and write your response. Okay, let's go ahead and turn the page. 195. So 195, number 4, says a dairy farmer sells milk at a local market. The graph shows the price they charge for different amounts of milk. All right, letter A. What is the slope of the line? You guys go ahead and figure that one out. Okay, hopefully you came up with 5 or 5 over 1. Okay, so that's going to take us down to letter B. How much does the farmer charge for half a gallon of milk? Well, we need to understand what this 5 over 1 means. This 5 over 1 means $5 because that's the rise, right? This is our rise. If I look at my graph, my rise is the price. It's how much is going up. Over the run, and that's the amount of milk. So that is in gallons. So $5 per 1 gallon. Okay, so if we keep cost consistent, how much would he charge for a half gallon of milk? Well, to get 1 gallon, we would have to divide it by 2 to equal the half gallon, which means I'd have to come up here to the $5, divide that by 2 to equal what a half gallon would be. So $5 divided by 2 gives you $2.50. 1 divided by 2, that's our half gallon. So our solution for this one would be, we would say, they charge $2.50 per half gallon of milk. Okay, number 5. Looking at number 5, it says the graph shows the walking speeds in miles per hour for Khalid and his daughter. Khalid's speed is represented by line A. His daughter's speed is represented by line B. Okay, so line A is Khalid. Line B, that's his daughter. So the question is, who walks faster? And how can you tell who walks faster? By looking at the graph. All right, so if we look at the graph there, we want to find whoever has the greater rate of change. Remember, rate of change also means slope. So whoever has the highest slope would walk faster. So if I look at Khalid, I can pick a point right here at 0, and then if I go up here to my next point that goes through the corner of a box, would be there at 1, 4. Okay, so if I'm just doing rise over run, so rise over run for Khalid, he has to go up 4 and over 1. So 4 over 1, and I'm going to say that is Khalid's. Okay, if I look at his daughter, I use the same point to start with, and maybe the next point is right there. So my rise on the daughter there would be just up 1 to get to the level of the next point. So up 1, and then you have to run over 4. So it's the reciprocal of Khalid's. Okay, so that's his daughter. If I compare the rates, I see that 4 over 1 is greater than 1 over 4. Okay, so the slope of line A is 4 or 4 over 1, which means Khalid's walking speed, the 4 represents the miles, and the X represents there is your time. So it would be 4 miles per hour. Okay, the slope of line B we look at, we got 1 over 4. So his daughter's walking speed is a little bit slower. Also 1 over 4, we know we could represent it as a decimal, 0.25. So her walking speed is 1/4 mile per hour, or we could say it's 0.25 miles per hour. Okay, that is it for today.